Hi everyone, we'll be waiting 2 to 3 minutes before starting the webinar to accommodate for the rest of the folks who are in the middle of connecting. Welcome everyone. Thanks for joining us and thanks for being part of our community. My name is Valen Kolika and I'll be your host for today. A few reminders before we start. If you have issues viewing the stream at any time during the presentation and are using the web browser version of Teams, please refresh your browser. And if you're using the desktop app of Teams, please exit and rejoin. Please note that this webinar is being recorded and will be shared publicly. We will post the recordings on our community at aka.ms/security-webinars. Closed captions in several languages are available during the live broadcast, and you can enable them by clicking on the CC button located at the lower right corner of your screen. Feel free to ask questions at any time by typing them in the live event Q&A window by clicking on the Ask a Question button. Be aware that any questions you post will be publicly visible. However, if you prefer, you can post your question anonymously by checking the box right below where you have entered it. Now, we often get many questions on these webinars, and we will do our best to respond to all of them in real time. In the event if the answer was not provided, or if you have additional questions post the event, please don't hesitate to raise them on our Azure Network Security forum at aka.ms/Azure Network Security Community. If you're listening to this after the fact as a recording, that's also a great place to ask a question. We love to hear your feedback on how we can improve these webinars, and you can do so at aka.ms/security-webinar-feedback. I would also like to invite you to join our public community by visiting aka.ms/security-community. This is the best way to ensure you don't miss any future webinars or major announcements. On our community, you can speak directly to our engineering teams that create our security products. You'll be able to influence our product designs and get early access to changes by doing things like participating in private previews, request features, give feedback, review our product roadmaps, register for events, or join webinars like this. We believe that the best way to improve our products is by removing any barriers between you and the people that create them. So we hope you'll join us. In today's session, Ashish Kapila will guide us through managing application and network connectivity with Azure Firewall. Ashish is a senior program manager with our Azure Network Security team. And without further ado, I'll turn it over to him. Ashish, the floor is yours.
Thank you, Alan, and good day, everyone. As Valen said, today we'll be looking at Azure Firewall and how it can help you, the features and the capabilities, and how it can protect the Azure resources. My name is Ashish Kapila, and I'm the Senior Program Manager in the Network Security Engineering team over in Microsoft. So before we start, I just want to kind of have a look or kind of show this to you, saying what all is there from an Azure networking services perspective. As you can see, we have multiple services for Connect, multiple for Protect and Deliver and Monitor, and we are focusing on the Protect side of the things. So you may have joined our previous webinars on Azure WAF and DDoS, and today I'll be covering Azure Firewall. And on 3rd December, I'll be presenting Azure Firewall Manager as well. And so from a Protect perspective, these are the cloud native services which you can use. And the focus today will be the Azure Firewall. How Azure Firewall fits in when it comes down to zero trust. As you can see, Azure Firewall sits right in the middle. It can help you from an application protection and segmentation perspective. You can define your parameters, you can define how the traffic flow works between spoke networks and or between the client networks and the internet, or even if you have a hybrid kind of a topology where you have on-prem connectivity, you can control the traffic flows from Azure to on-prem and on-prem to Azure using the Azure Firewall. So what is Azure Firewall? Azure Firewall, as I said, it's the cloud native firewall. It help govern the traffic flows between multiple spoke virtual networks, and everything goes through the central virtual network, which is your Azure Firewall. It is highly available as it's cloud native. It is auto scalable as well, so it auto scales based on the traffic flowing through the firewall, and it can support up to 30 gig throughput through the Azure Firewall, and you don't have to do manual scaling. It auto scales, as I said, based on the traffic throughput. From a traffic flows perspective, you can control from layer 3 to layer 7. So you can NAT the traffic, you can do application traffic filtering using FQDNs, and we'll cover that later on. It also protects your virtual network, so you can filter the traffic which is going from spoke networks to Azure Firewall to internet or to your on-prem. So you can kind of have this centralized firewall which is controlling all the traffic flowing in either direction between spoke, on-prem or internet. Azure Firewall also integrates with Azure Security Center. What that really means is that if you are looking to use just-in-time to protect access to your VMs, and if you are trying to access it from the internet, then you can use just-in-time, and Azure Security Center will create the rules in the Azure Firewall to allow the traffic coming from internet to your internal VMs. So you do that from a logging and monitoring perspective. You can use Azure Firewall to log traffic to a log analytic workspace, or you can do like event hubs to integrate with the third-party SIEM. Azure Firewall also integrates with Sentinel using the built-in connector. So if you're using Sentinel, you can use the built-in connector to use Azure Firewall or to forward the logs to the Sentinel. As it's cloud native, if you're big on automation or if you're looking to automate everything, then you can use your existing CI/CD pipelines using Terraform or REST or PowerShell. You can do all that and you can manage your Azure Firewall from a DevOps perspective. My Azure Firewall does have the built-in threat intel as well, which uses our Microsoft Security Graph to protect both inbound and outbound traffic from malicious IPs and FQDNs. These are some of the key features which I just want to highlight from an Azure Firewall perspective. As I said, the Azure Firewall can control the traffic flow from layer 3 to layer 7. So I will just highlight the key points here. As in the first one, you can see from an application rules. So application rules are just basically the rules for your web traffic, so HTTPS or HTTP and MS or SQL Server traffic. The key here is that we have something called FQDN tags. So FQDN tags is usually just the Microsoft services, for instance, like Windows Update, Windows Virtual Desktop. So if you want to kind of allow traffic from your internal VM, for instance, to Windows Update, you can use these FQDN tags. So from a rule or a policy management perspective, you just create a rule saying allow all my VMs or this particular VM going to Windows Update, and you just select the Windows Update FQDN tag. You don't have to specify the list of IPs or the list of URLs, which you usually have to when you have to allow a particular Microsoft service on a firewall. Then the next one, which is key in Azure Firewall, is service tags. So service tags are basically if you are trying to allow access to service endpoints. So when I talk about service endpoints, things like your storage or key vault access. If you want to allow that kind of traffic through the firewall, Azure Firewall, then you can use the service tags. And when you use the service tags, again, you do not have to specify any IPs or URLs. You can just say that I only want to allow traffic from these virtual machines can only connect to a key vault, which is in UK South or in any other data center. So you can even pick which data center you would like to allow from a service endpoints perspective. Azure Firewall does the NATing, so it does both destination NAT and the default NAT. So, and these are all configurable as well. So when I talk about DNAT, you can publish your internal servers onto internet. For instance, your management server on port 3389. You can use DNAT to publish that server onto internet using Azure Firewall. From an SNAT perspective or the source NAT, you can configure Azure Firewall to say what you would like to NAT the traffic with and what you don't want firewall to NAT. So you can configure everything in there. So if you're using like public IPs within your network, then you can configure Azure Firewall to not do the SNAT or do the SNAT, whatever you prefer. Threat intel, that is the key feature within the Azure Firewall. As I said, threat intel is based on our Microsoft Security Graph, which is used by all our services like Azure Security Center and other threat intel services. What it does, it protects, as I said, both inbound and outbound traffic through Azure Firewall from malicious IPs and FQDNs. And this is like a live feed and it constantly gets updated. So you get that protection both when the traffic is coming in through the Azure Firewall and when the traffic is going out. From the monitoring perspective, Azure Firewall integrates with Azure Monitor, so you can get all the logging and the matrix as well, which we will cover in this session. And this is the key feature, which is the scale and availability. Azure Firewall auto scales. It is highly available. You can have an Azure Firewall in an availability zone, and when you have that Azure Firewall in an availability zone, you get 99.99% SLA. And this is fully managed because it's cloud native. So you don't have to go and update like firmwares, or you don't have to go and manually scale your firewall when there's a spike you don't have to do anything. And as you do not manage it, and if you implement in availability zone, the SLA is 99.999%, which is quite critical for any business. These are the recently released features from an Azure Firewall perspective. We have added the Windows Virtual Desktop integration. So you have an FQDN tag for Windows Virtual Desktop as well in Azure Firewall, which you can utilize to allow your policy management and allow traffic to Windows Virtual Desktop if you're using it. We also have a force tunneling feature. What force tunneling really means is that you can configure Azure Firewall to forward any internet bound traffic through another network appliance, or like if you're using, for instance, Checkpoint or some other Palo Alto or any other device, you can configure Azure Firewall to forward all internet traffic to these these NVAs. Even if it's on-prem, you can still configure Azure Firewall to forward any internet traffic to them. We also added the custom DNS and the DNS proxy feature. So we will cover this in detail later on, but just to give you an idea, by default, Azure Firewall uses Azure DNS, but now you can configure Azure Firewall to use your corporate DNS server. So what that helps is that you can now resolve the internal names as well from an Azure Firewall perspective. And also from a DNS proxy side of things, you can configure Azure Firewall as a DNS server. So you can configure your VM clients and point it to Azure Firewall for DNS, and Azure Firewall will act as a DNS proxy for these VMs which you point Azure Firewall to. Traffic filtering. We have gone GA with this also with custom DNS and DNS proxy. As I said, that with custom DNS, Azure Firewall can resolve internal names. Then you can also put like now FQDNs in the network rules. Earlier, it was only that you can only have IPs in there, but now you can use the names as well, or FQDNs. From a management perspective, we have added IP groups. So IP groups is just a collection of multiple IPs or CIDR ranges. So you can add multiple IP ranges. For instance, you say for my Active Directory server, you make an IP group and add all your domain controllers IPs in there, and then use that IP group when configuring the application rules or network rules. The SNAT configuration, as I was saying, that this is fully customizable. So you can configure Azure Firewall to say what you want it to NAT and what you don't want it to NAT. And you can configure it from a UI perspective or PowerShell or whatever you want to use. We recently had the HIPAA compliance with Azure Firewall, plus it is ICSA lab certified. So if there's a compliance or a certification requirement from a business perspective, the Azure Firewall is compliant from HIPAA and ICSA perspective. Right, so this is kind of a table where we are just kind of putting a comparison with NVAs as to where Azure Firewall is, what is on the roadmap, plus what are the key features which you will have in Azure Firewall and not in an NVA. So as we discussed, that you can use FQDN filtering, where you can configure FQDNs to allow traffic from a network rules or from an application rules perspective. It does like almost everything as an NVA, but these are the key features. As it's cloud native, it auto scales, right? Which NVAs don't. You have to manually scale them if you like. Plus it is highly available because you can have Azure Firewall implement in a availability zone, and you can use your DevOps pipeline. So if you're using REST or CLI or Terraform, you can use that. You do not have to manage it, so zero maintenance for this, and it is integrated with Azure Monitor, so you get the monitoring piece as well. From a roadmap perspective, as you can see that, yes, we do not have the deep packet inspection available right now with SSL termination, but yes, it's on the roadmap. Same with the traffic filtering rules by URI, which is basically your TLS termination or inspection. If you're using multiple Azure firewall and you won't like to centrally manage it, you can use Firewall Manager, which we will have a different session about, and we'll cover that. Application and user aware filtering rules, again, it's on the roadmap. If you're planning to use IPsec or SSL VPN, we've got Azure VPN Gateway, which you can utilize. Plus the advanced functionalities like sandboxing, again, these are on the roadmap. But the pros, as I said, zero maintenance, which I think is quite a differentiator when it comes down to making a decision whether you would like to use an NVA or a firewall. And as it's zero maintenance, or you don't have a fully managed firewall, that's like a definite plus when it comes down to Azure Firewall. Right, so these are the different rule types which we have in Azure Firewall. First one is our DNAT or Destination Network Address Translation. So if you're trying to publish any of your internal resources or Azure or on-prem, you can configure DNAT rules on the Azure Firewall to allow traffic coming in from internet to these internal resources. As I said earlier, you will also get the threat intel. So if there is malicious IPs trying to connect to your services, the threat intel will drop the traffic as well. So you get that protection when it comes down to DNAT rules. Network rules, DNAT rules are applied first. So if you have a DNAT rule, a network rule, and an application rule, the first rule which will be processed would be a DNAT rule. And then after that, you have network rules. So network rules control all traffic for any protocol, and you can either specify FQDN or IP addresses. Network rule have a higher priority than application. So if you have a network rule saying allow port 80 to a specific IP, then when you try to access that particular application, network rule will be the first one which will be processed. And if the traffic is allowed through a network rule, then we'll not look at the application rule for the traffic. From an application rules perspective, application rules are pretty specific. They are for your web traffic and your SQL traffic. And again, you can use FQDNs plus the FQDN tags when you're creating rules in application. If you're trying to allow access to Windows Virtual Desktop or AKS or Windows Update, you can use the FQDN tags. You don't have to put in the list of the IPs and the URLs in your rule and have to maintain it. You can just use the FQDN tag for it. So yeah, so as as of today. So FQDN tags, as I said, it's for well-known Microsoft services, as you can see over here. And the FQDN tags can only be used in an application rule perspective when you are required to access that traffic, that application through the firewall. And you can use any of these FQDN tags which are available, and we keep updating them. We have recently added the Windows Virtual Desktop and AKS. And the benefit of it, the benefit of FQDN tag is that you do not have to maintain any IPs, and it's all done in the background. So you know that your service will not be affected if it's going through the Azure Firewall, if you're trying to access any of these services through it. The next one is the service tags. As I was saying, service tags are basically your service endpoints. And over here, I hope you can see the screenshot. These are like just some of the services which I'm trying to highlight here, but you can find all the services which are available from an Azure perspective. And you can use the service tags in the network rule. And you can even specify, like, as I said, again, if you want to have Azure Key Vault access, but you only want to allow Azure Key Vault access in the UK South, you can specify that service tag that traffic only traffic going to Azure Key Vault in UK South is only allowed. So you can go to that level as well. Threat intel, as we kind of discussed it briefly earlier. So this is based on our Microsoft security graph, and this is the list the database which we have on malicious IPs, which keeps updating malicious IPs and domains, and works both from an inbound and outbound perspective from an Azure firewall. You can configure the threat intel in either deny mode or alert mode, or you can just turn it off if you're not looking to use it. And it's pretty easy, like from a UI perspective, you can just configure it like what you want. Plus you can also say if you want like to whitelist any specific IPs or any false positive you have, then you can just create those, add those IPs in here in the UI itself. Right, so this is the recent feature which we've added, the custom DNS and DNS proxy. As I said, by default, Azure Firewall uses the Azure DNS, but if you would like, you can also configure now custom DNS, which means you can resolve both internal and external names using your corporate DNS. What this helps, that you can create network rules with FQDNs, plus you can configure Azure Firewall as a DNS proxy, so you can point your infrastructure to Azure Firewall as a DNS server, and then you can configure the rules with FQDNs as well. And again, this is just like a screenshot of how you can configure it from the UI perspective. FQDN filtering in network rules, as you can see over here, this is where we are just trying to highlight like that you are trying to allow access to sync time with the time server, and you're just in the destination type, you can just say target FQDN and then the address and the port number. So it makes it easier instead of putting the IPs in there and then maintaining it. And yeah, this is the key that DNS proxy has to be enabled on the Azure Firewall if you're planning to use FQDNs in the network rules. And why this is important, because if the client is using Azure Firewall to resolve the name, then it will resolve the name to the same IP which Azure Firewall used. So Azure Firewall will first, like if you're using custom DNS and DNS proxy, then Azure Firewall will use your corporate DNS to resolve the name, and then it will maintain that name and IP in the cache, or not in a cache, but in a table, IP table. And when the client will also try to resolve the same name, then the Azure Firewall will have that in the IP list, and it will give the same IP back to the client. So client and Azure Firewall resolves to the same name, same IP. So if there is a, like for instance, time.windows.com resolves to multiple IPs, then you know that based on the name resolution, both Azure Firewall and the client is using the same IP address to connect to this destination address. So this is the force tunneling feature which we were discussing earlier. So force tunneling redirects all your internet bound traffic from Azure Firewall to your on-prem firewall, or you can just forward it to another NVA if you would like to do some additional inspection on the traffic. And this is just a screenshot where you can see that when you enable force tunneling, you have a management subnet and you have a management public IP which is used to forward the traffic to the NVA or the upstream firewall. So over here, as you can see, that any spoke-to-spoke traffic will still be filtered by Azure Firewall, or will still be controlled by Azure Firewall. But additionally, you can just forward all your internet bound traffic over to another NVA and then forward it to the internet. So Azure Firewall now integrates with both ASC and Azure Sentinel. So as you can see here, from an Azure Security Center perspective, you can get the just-in-time access. So if your clients are trying to access an internal VM which is protected with just-in-time from internet, then you can configure, or then you can utilize Azure Firewall. If you're utilizing Azure Firewall, then just in time from internet will work, as Azure Security Center will be able to create DNAT rules to allow that specific traffic from internet to that VM which is protected by just in time. From an Azure Sentinel perspective, we have the connector now for the Azure Firewall, and you can configure the connector to send or to integrate with Azure Sentinel. And with Azure Sentinel, you can utilize the data which come from Azure Firewall to create workbooks or playbooks. So if you want to automate a response action using Sentinel, you can always do that. Just as an example, if you have a client which is trying to connect to a malicious IP or malicious FQDN multiple times, and if you see that threat intel alerts being raised, then you can always configure Azure Sentinel to say, if you see a client over a period of time raising too many threat intel alerts, then create a deny rule in Azure Firewall to block access to that client, block access to internet from that client. From a log diagnostics and monitoring perspective, Azure Firewall can forward the logs to a storage account. If you're using a third-party SIEM or an on-prem SIEM, you can stream it to an event hub, all the logs, and integrate your SIEM with Event Hub, or you can send logs to the log analytics workspace, which you can use to create, like we have a workbook, which I'll show you later, which you can kind of use to visualize all the data. There are two types of logs which we have in Azure Firewall. One is your application rule category and then network rule category. So application rule category is basically log all the traffic which is being processed, either allow or denied, from an application rule perspective, which is HTTP, HTTPS, and SQL traffic. From a network rule perspective, or the Azure Firewall network rule category logs all your network rule based traffic. Plus, it also has your threat intel. So any threat intel alerts, you will see that in the network rules. And this is just a screenshot showing how you can just configure it, and you can choose either of these options to forward the logs. So you can use storage account, event hub, or log analytic workspace. As Azure Firewall integrates with the Azure Monitor, so you can see various metrics from Azure Firewall, and you can see like what is the throughput and what is the SNAT port utilization or the data processed. You can see all that information within the matrix for your Azure Firewall. Yeah, so this is the workbook which I was talking about. So if you have configured Azure Firewall Diagnostics to send all the logs to a log analytic workspace, then you can use our existing workbook. As you can see in the screenshot, it gives you a good visualization of all the data which you have in your log analytic workspace, and you can have like the firewall overview, the application rules, statistics, network rule, DNS proxy, so all different specific log types. You can look at that, and you can download it from our GitHub repo as well, and that's the link for that. Right, so when it comes down to the other network security products which we have, how does Azure Firewall fits in? So when we talk about the application gateway, you can use the web application firewall on it. Application gateway will protect your application. It's a reverse proxy solution, and web application firewall protects your application from layer 7 application vulnerabilities, like the top 10 OWASP, like SQL injection and things. You can have an Azure Firewall deployed so that you can either protect it, like depending on the strategy which you have, you can place an Azure firewall to combine layer 3 protection with application gateway from a layer 7 side of things. With NSGs and Azure Firewall, they're pretty complementary, but the main difference is that Azure Firewall works from layer 3 to layer 7. And with Azure Firewall, you can protect all the traffic flows in your organization, whereas with the NSGs, you can protect your VNet or subnet to subnet traffic flows, and it works pretty good when you have an Azure Firewall and NSG in your environment. And this is one of the requirements if you're looking to use just in time. With Azure Firewall, you need an NSG as well with that. Service endpoints, you can have service endpoints enabled on a virtual network itself, or you can use the Azure Firewall service tags if you would like to log, like not just log, but control all the traffic, even to the Azure services. And if you're planning to do that, then you can use Azure Firewall Azure Firewall and the service tags to kind of control the traffic to your service endpoints. And lastly, I just wanted to kind of show you this architecture of a hybrid hub and spoke. And as you can see that this is the hub virtual network where I have all my security controls and my shared services. And these are my spoke network. So this is used by a PaaS service or an app service, whereas this one over here has my VMs or infrastructure. And you can see that all the traffic flows which has to go either from spoke 2 to spoke 1, everything can be controlled by the Azure Firewall. And similarly, if you're trying to connect over to your on-prem network, or on-prem is trying to connect to your spokes in Azure, then you can govern all the traffic flow through your Azure Firewall as well. And you can see, like in the hub network, you have your application gateway, you've got your DDoS protection and everything as well. So yeah, that's pretty much what I have. Over to you, Varun.
Thank you, Ashish. Let's see if the folks have some questions. We have plenty of time for that, although plenty of them has been already answered, and I'm sharing here the link for the poll EV, and let me also share my screen so we have a visual on it. Okay, let me see. I think I saw a question coming in. I'll go ahead and publish Anil's question on poll EV so we can break the ice with that. There we go.
So I'm specifically looking to monitor SQL traffic. So does the Azure Firewall fits there, or should I look for some other solution? So in Azure Firewall, if you're planning to access like your SQL servers from spoke different networks, then yes, you can use Azure Firewall application rules to allow or to control the traffic to these SQL services. From the logging perspective, you will see the logs going through the application. So in the application rule category, you will see that traffic, not traffic, but the information around that. So your public IP attached for firewall, is that for outbound only? No, the public IP can be used for outbound and inbound. So you can create a DNAT rule, which is inbound on the firewall, and use that public IP to publish your internal services.
Thank you, Ashish. And we have an ask, if you don't mind going back on describing on how just-in-time would work between Azure Firewall and NSG.
Right. So the main thing is that with just in time, if you're trying to access a virtual machine from internet, right? Then if you're using Azure Firewall and if you enable just in time, what Azure Security Center do is it creates a DNAT rule in the Azure Firewall to allow the traffic from internet for that particular client IP, which is requesting access to that VM. And after the specified time, like if you have allowed that access for an hour, then that rule automatically gets deleted from the Azure Firewall, and Azure Security Center kind of deletes that rule. Similarly, like in NSG, right? So when you are trying to access a VM internally with just in time from your corporate network, then a rule gets created in the NSG for a specific time. And once that time is over, that rule gets deleted from the NSG.
Thank you. We have a couple more here.
So Azure Firewall cannot block unauthorized SQL command. It can only allow the SQL traffic through. It's not looking at the commands which you have. Okay. Central management of all PaaS firewall is currently in the pipeline. Will this be implemented on a VNet level? So VMs and private endpoints also get tunneling. Currently managing UDR per subnet is a lot. Yeah, so from a, like if you're talking about the multiple Azure firewalls, then yes, you can manage them using the firewall manager. But if you're talking about like a SQL firewall, like SQL PaaS SQL service firewall, then yes, that capability isn't there in the firewall manager. But yes, we are tracking a feature for this, and we'll keep you updated there. Azure Firewall public IP addresses, are they reserved and can they be preserved? So they are not reserved as such, but if you're, for instance, you're deleting an Azure Firewall and recreating it, you can use that existing, because it's a public IP, is a separate entity. Unless you delete it, you can't reuse it. But if you haven't deleted it, then you can always reuse it with the Azure Firewall. What's the difference to use Azure Front Door and Azure Firewall? So Azure Front Door is again a global service to publish your applications on HTTP and HTTPS, whereas with Azure Firewall, you can control both egress and ingress for all ports and protocols. So that is the big difference between Front Door and the Azure Firewall. If you're looking to protect your application and you would like to use the web application firewall component, then that's where you would choose Azure Front Door, because with Azure Firewall, we do not do inbound SSL termination, so we cannot look at the traffic, whereas the Front Door can see the traffic because it's a reverse proxy solution. Is there anything in Azure Firewall for threat signatures, like some of the? So we have IDS, IPS capabilities on our roadmap, and that's pretty much what I can say right now. Is there anything? Sorry, is feature like SSL orchestrator, service chaining? Yes, so we have something like that on our roadmap. Can you explain how Azure Firewall integrate with Azure Policy? So as of today, we do not have that integration with Azure Policy, and we are working on that. It's on our roadmap. Are WebSockets supported? So WebSockets are supported when you talk about the inbound or outbound both scenarios. The only key piece is that Azure Firewall has a TCP idle timeout of 4 minutes. So if the WebSocket will run longer, we have to make sure that there are keep alives going. Otherwise, that traffic will be dropped. Can you please help describe more on threat intel? If intel blocks some of the customer IPs as malicious, we want to whitelist. Yeah, so you can whitelist any false positives on the firewall, as I showed you in this screen, in the UI, and you can also kind of open a support case with us, with the Microsoft, and we can help you to whitelist that IP as well. In the future, one can enable tunneling of all traffic with a VNet through not needing to handle UDRs. So yeah, UDRs, again, it depends how you are configuring them and what you're using them for. The main thing is that if you're using Azure Firewall in a hub virtual network, then you have just one UDR, which is your default UDR pointing to the Azure Firewall internal IP. And Azure Firewall is controlling all the traffic between different virtual networks, including your on-prem connectivity. How does Azure Firewall, Azure Front Door differ from Application Gateway? So Azure Front Door, so both Application Gateway and Front Door are reverse proxy solution to publish your internal application or Azure applications. So the key difference is that Front Door is a global service. So if you have an application in UK and the users are accessing that application from all over the globe, then you would choose Front Door because it's a global service. If your application resides in UK and the user base is also in UK, then you go with an application gateway. Where can I see roadmap features when they are delivered?
For this one, I was just going to refer the folks to join the private preview, which I just posted the link on the chat. Sorry, I didn't mean to cut you off.
No, that's fine. Does the Azure Firewall have an equivalent of NetFlow? So not at the moment. Again, this is something we have on the roadmap. Yeah, and the only logs which you see is from the diagnostic logs, so network rule traffic and application rule traffic. But yeah, we don't have anything at this time from a equivalent of NetFlow. Can you explain more about Azure Firewall prices? I do not have that information right now, but you can always look at our Azure or cost calculator on our website, and you can see the pricing there. Yes, WEF can still be used even if the application is internal, depending on how you're configuring it. Is there a way to export or import Azure Firewall config? Yes, you can do that. If you go to the templates, you can export a template. Plus, you can use Azure Firewall policy as well. So there are two options. One is Azure Firewall config and the other one is Azure Firewall policy. Depending on which option you're using, you can export a template and you can get that config. So with virtual WAN, so this we are going to cover in my next session as well. But yes, with virtual WAN, you can have an Azure Firewall as well. Any support for service type object groups similar to IP object to group several destinations? Again, yeah, it's a ask. We have that on the roadmap as well from a destination port group or port group perspective. So traffic manager is your DNS. So if you're looking to load balance based on DNS, then you use traffic manager. Whereas with front door, this is more again from an application HTTP and HTTPS perspective. Should application gateway traffic be directed through Azure Firewall? So again, it depends on a scenario. The key point here is that if you're putting Azure Firewall in front of the application gateway, then the traffic coming from internet will hit the Azure Firewall, and Azure Firewall will NAT that traffic with its own IP address. So when it will get to application gateway, it will only see Azure Firewall internal IP. And there is a good article on our website where you can see the different architecture when it comes down to mix of application gateway and Azure Firewall.
Okay, we've reached the end. Just wanted to remind folks, as Ashish mentioned earlier, if you don't mind just muting your, well, I can do that from my end, I guess. I could hear myself echoing from the other side. Okay, so just wanted to remind you that on Thursday we meet again with Ashish on the topic of getting started with Azure Firewall Manager. And if you haven't registered yet, please do so by visiting us at aka.ms/security webinars. And in case we missed to answer your questions or you have additional questions, you can visit us on our Azure Network Security forum at aka.ms/Azure Network Security Community. I would like to close this webinar by thanking Ashish for an awesome presentation. And already looking forward to the next one. Thank you to the rest of the team who helped answering the questions. And most of all, I want to thank all of you for being part of our community and for joining us on these webinars. We hope to see you next time. And goodbye.